Alright, sorry, so I had to make a new video, it cut off, but so basically what we're trying to find here is the change in the table of the y values. So we also want to make sure that the x values go up by 1, and then we're going to find the change in each increment. Once we found the change in f, meaning the next function, or the next y value, subtract the last y value, then we're going to decide if it's a exponential function, linear, and then if we're going to make a formula. So go ahead right now, pause it, find the change between each value and place it here, and then decide whether it is a linear or exponential function. Okay, if you're pushing play now, you should be able to have said, okay, -3 to 1 is a +4, 1 to 5 is a +4, a +4, a +4. When I know that there's a constant rate, I know that the formula is a linear function. So now I know that I'm going to use the y equals ax plus b. We're going to use ax still because we're using that in our notes in the front. And then I'm going to find the formula. Go ahead right now and try to find the formula. Push pause. Alright, so if you found the formula, you should have found something like this. Y equals, the rate was 4, x plus, now when you try to find the b value, it's when y is 0, was an x when 0. X is 0, and we don't have that. But if I went 1 backwards, I would know that I would take 4 more away, so I would be at -7. So actually, my formula should be y equals 4x plus -7, or y equals 4x minus 7. Next, go ahead and try to do the entire chart formula type in formula yourself for the second one. Push pause. Alright, if you're coming back together, you should have realized that this was a +4. This became a +12. This became a plus, gosh, I don't even know, 36. And this became a plus, this is a ×3 pattern. So this became 108. Now I notice that the plus pattern is not the same, it's not constant. However, there's a multiplication rate that is, and so I definitely know that this is an exponential function, which means that I'm going to use y equals b times a to the x, where b is the initial and a is the growth formula, or the growth rate. So I know that the growth rate is a ×3 growth. So I can start there and put 3 to the x. Now I still need to figure out my b value, my initial, but this case was actually given to me. X was 0, y was 2. So my formula would be 2 times 3 to the x power. Flip over your paper. Now I want you and your teammates or your partner to answer this question number 2 about Terrence. Alright, so the answer here, if he looked down at the second column of the table, he noticed that it did not go by a constant rate. It was a multiply by 3 each time. The problem with this is that he is not correct when he says it's linear, or when he says it can't be it could be exponential, because we have to also look over here. This went up by a very different amount as well. This went up by 1, then it went up by 3, then it went up by 9, and then it went up by 27. So if you see, there actually was a constant rate of change, because we have to make sure we also look at the x values. If they don't increase by the same, we have to make sure that we don't just assume it's exponential. We need to make sure we're also seeing if this increases by the same amount. So Terrence is actually incorrect. It could be modeled with a linear function because it is a constant rate. If you were to fill in all the values in between here, it would be going up by 2. Alright, number 3, go ahead and try with your partner and then push pause and we'll bring it back together. Okay, so if you and your partner figured it out, the plan they should choose for a 2-week, which is 14 days, the plan that you should choose is a difference between a linear function and a exponential function. If we look about plan 1, he has $5 per day. So $5, $10, $15, $20, $25, etc. Plan 2 has a plan where it actually just begins at 1 cent, so 0.01, and then it doubles every single time. 2 cents, 4 cents, 8 cents, 16 cents, etc., etc., etc. Now, we need to figure out which one after 2 weeks, aka after 14 days, is more expensive. And we also need to decide who we're thinking about. Jaden has the dog walking business. We're not answering if it's better for Jaden, we're answering if it's better for Mrs. Maroney, meaning she wants the cheaper plan. So yes, I could really count this out all the way to 14 days. I don't even have room. And this would be 32 cents, 64 cents, $1 and let's see, it's 28 cents, $2.56, 5, 12, 10, 24, 20, 48, 40, 96, and 81, 92. So it'd be $81.92. And I could do the same thing here. 30, 35, 40, 45, 50, 55, 60, 65, 6, 7, 8, 9, 10, 11, 12, 13, and the 14th day would be 70. Now, obviously she should choose plan 1 in this case, but if you were to make these equations, you could also have done plan 1. I have a rate of $5, so that's my A, and my initial value at 0 would be $0 because on day 0, I don't charge $0, or I don't charge any. Plan 2, again, is also 0 when you start, and it's doubling. You're gonna actually start at 1 cent because if it's 0 times 2 would be nothing. So 0.01, 1 cent times 2, the doubling rate to the x power, and you could compare that way. So the answer is, which one should she choose? She should choose plan 1. Sorry, that was very crooked. All right, flip over your paper. For the next 3, you're gonna decide whether you think they're exponential functions or linear functions. And then if they are linear, you're gonna make a linear function for that table, and if it's exponential, you're gonna do the same thing. You're gonna make an exponential function. So go ahead and pause, try all 3, and then I will give you the answers when you push play. All right, so you should have noticed that this one increased by 20 every time, 40, 20, 40, and then 80, so it was doubling. So the pattern is a times 2, which means it's exponential. So I know it's b times a to the x power. I'm going to keep going down first, so then I realize x's all go by the same, so this is going to be okay. I can just look at the y's. -2, up 2, up 2, up 2. So this is a +2 pattern, which means it's linear. I can use a, x plus b, or m, whatever you want. Same thing here. I notice they all go up by 1. That's great. This one is going to decrease. This decreases in half. Or it's minus 42, minus 21. But I'm noticing that it's actually dividing by 2 each time. Which, instead of dividing by 2, we could say that's multiplying by 1/2. It's definitely not decreasing at the same exact amount. It's decreasing at a rate that's dividing in half, so this is also exponential. And now I just have to find my rates, which I already did, and my y-intercepts. So for the first one here, my rate was times 2, so that's my growth as my A. And my initial value, it doesn't show me, it's 120, but if I went 1 backwards, 0. If I'm doubling, that means that this would be divided by 2 if I'm going backwards, so it would be 10. So I put my 10 as my initial value. And there's my answer for number 4. Number 5, it's a linear. It was a +2 pattern, so my A is 2 times x. My B I still need to get, so when x is 0, I don't have that, but again, I can use my pattern and work backwards. If it's +2 forwards, then it's going to be -2 to get the other way. -2 subtract 2 is now -4. So 2x minus 4 is my linear function for 5. And finally, 6. We know it's exponential. We know the rate is cut in half, so it's a decay, 1/2 to the x power. And I need to decide, okay, what is b? Well, if it's dividing in half on the way forward, it's actually going to multiply in half to get back to 0. Not multiply in half, sorry, multiply by 2. Because if it's getting divided by 2 here, we're going to multiply it by 2 this way. So 84 times 2 is 168. And that would be my initial value here, which would make my equation. All right, so really the reason I did all this is because on your Module 3 exam that's coming up, you need to be able to create linear functions, exponential functions. You need to know the difference, which one you use and when and why. So I hope this helped. Your homework tonight is going to be part 1 of the packet. It's all random stuff that's on your Module 3 review, so please be sure you do it. And that's all I got. So I'll see you tomorrow. Bye.